Welcome to the mathematics on my channel. In this video we are going to solve interesting integral. Integral from 0 to infinity natural log of x over 1 plus x square plus x to the fourth power. So we can take our integral is equal to j, and as a first step I am going to break the limits. So here integral from 0 to 1 natural log of x over 1 plus x square plus x to the fourth power dx, plus now here 0 to 1, then 1 to infinity natural log of x over 1 plus x square plus x to the fourth power dx. Okay, then I am going to rewrite this integral from 0 to 1 natural log of x over 1 plus x square plus x to the fourth power dx, plus now for this integral I am going to take a substitution. So we can take x is equal to 1 over u, because if you take this substitution, after the substitution we will have same denominator. So now derivative, we know dx is equal to minus 1 over u square du. Now we should change the boundary. So lower limit when x approaches to 1, we know u also approaches to 1. So here 1. When x approaches to infinity, upper limit we know u approaches to 0. So 1 to 0 natural log of, now x we know 1 over u over here 1 plus x square. So 1 over u square plus x to the fourth power 1 over u to the fourth power, and dx we know minus 1 over u square du. Then here again rewrite this integral natural log of x over 1 plus x square plus x to the fourth power. Then here we can change this boundary. When we change the boundary, this minus get cancelled, so we can write integral from 0 to 1, and here we have natural log of 1 over u. We can convert u to the minus 1. Then we know here minus sign, so here minus, and here natural log of u, and here we have the variable u. We know the definite integral independent of the variable, so instead of u now we can use x. So natural log of x over here we know u, if we take common denominator u to the fourth power, then this u square get cancelled, and here we have 1 plus now instead of ux, so x square plus x to the fourth power over x square, so we can write in the numerator x square and here dx. Okay, now we have same boundaries, so we can take natural log of x over 1 plus x square plus x to the fourth power as a common factor. So we can write integral from 0 to 1 1 minus x square natural log of x over 1 plus x square plus x to the fourth power dx. Then what can we do? Okay, now I'm going to define an integral because okay, here I'm going to take in is equal to integral from 0 to 1. Here we have 1 minus x square times, now here natural log of x, but I am going to take x to the n, because if we differentiate with respect to x, we know here we have x to the n times natural log of x. So then if we plug in 0, x to the 0 power we know 0, and we will have this integral. So here also we have 1 plus x square plus x to the fourth power dx. Okay, now let us simplify a little bit. Here 1 plus x square plus x to the fourth power. Now I'm going to consider 1 minus x to the sixth power. 1 minus x to the sixth power. We know we can write this is 1 cube minus x square cube. Okay, then difference of two cubes, we know this is equal to 1 minus here x square raised to the 3 power, so x to the 6 power, and here 1 plus x square plus x to the 4th power, and this is equal to 1 minus sorry, here we have 1 minus x square, sorry, 1 minus x square. Okay, then instead of this part we can write 1 minus x to the 6th power or 1 minus x square. So we can write this is equal to integral from 0 to 1. Now 1 minus x square, here x to the n. Now instead of this part we can write 1 minus x to the 6th power over 1 minus x square. So here we can write 2 power. Okay, then here again we have dx. Now if we differentiate, we know here I dash of n is equal to integral from 0 to 1, here 1 minus x square times x to the n times natural log of x over 1 minus x to the 6th power dx. Okay, then if we plug in 0, here I dash of 0, we know I dash of 0 is equal to integral from 0 to 1, 1 minus x square, here x to the 0 power 1, and here natural log of x over 1 minus x to the 6th power dx. So in our main integral, I dash of 0 is equal to g, our integral, because we know here 1 minus x square or 1 minus x to the 6th power we can simplify as 1 plus x square plus x to the 4th power. So I dash of 0 is equal to g. Now we have a target, so let's evaluate I dash of 0. Okay, now I'm going to take in. So we know I of n is equal to integral from 0 to 1, here 1 minus x square raised to the 2 power times x to the n over 1 minus x to the 6th power dx. Well, now I think if you remember my previous video about the answer is natural log of golden ratio. So here in that video also we have this type of integral. So if you like to watch that video, I will add the link in the description and also make a card. So in that video we used this integral formula, integral from 0 to 1, integral from 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x is dx is equal to digamma of n minus digamma of m, digamma of n minus digamma of m. We evaluate this integral in a previous video. I will add the link in the description. Okay, now how to convert our integral to like this integral. Okay, first we can simplify here square. So in is equal to integral from 0 to 1, here 1 minus 2 times x square plus x to the 4th power times x to the n over 1 minus x to the 6th power dx, and here we have x to the 6th power. So I'm going to consider the derivative of x to the 6th power. So d by dx x to the 6 power. We know this is equal to 6 times x to the 5. So we can isolate 1. So we know 1 is equal to dx to the 6 power over dx times 1 over 6 times x to the 5th power. So now we can write instead of 1 we can write dx to the 6 power over dx times 1 over 6 times x to the 5th power. Now we can simplify. Here 1 over 6 is a constant, so we can take outside of the integral sign. So here 1 over 6 integral from 0 to 1. Here we can multiply, so x to the n minus 2 times x to the n plus 2 plus x to the n plus 4 over x to the n plus 4 over, here we have x to the 5th power, so x to the 5th power 1 minus x to the 6th power dx to the 6th power. Okay, then here now we can also simplify this x to the 5th power. We can take in the numerator as x to the minus 5 power. So we can write here 1 over 6. Now I am going to integrate with respect to dx to the 6 power. So we can write here 1 over 6 integral from 0 to 1. Now here I am going to take here, because here we have x dx. Now here dx to the 6 power, x to the 6 power. So I am going to take here x to the 6 power raised to the, now n here 5, so n minus 5 over 6, then minus 2 times x to the n plus 2 minus 5, we know n minus 3. So sorry, here x to the 6 power, sorry, x to the 6 power n minus 3 over 6. Now we know this 6 gets cancelled and we have x to the n minus 3. Okay, then here x to the n plus 4, so we can write plus x to the 6 power raised to the n minus here 5, so n minus 1 over 6 power over, now in the denominator we have now 1 minus x to the 6 power, and here dx to the 6 power. Okay, then now we can break this integral into two different integrals, because we need to apply this integral formula. So we can write now this is equal to in is equal to 1 over 6 integral from 0 to 1 x to the 6 power raised to the n minus 5 over 6. Then here we have 2 times x to the 6 power raised to the n minus 3 over 6. So I am going to take minus x to the 6 power raised to the n minus 3 over 6 over 1 minus x to the 6 power dx, then plus again 1 over 6 integral from 0 to 1, sorry, integral from 0 to 1. Then here we have x to the 6 power n minus 1 over 6, so x to the 6 power n minus 1 over 6 power minus, now here we have x to the 6 power n minus 3 power over 6, and in the denominator we have 1 minus x to the 6 power, here dx to the 6 power, here also dx to the 6 power. Okay, then we know we can apply this integral formula. So we should find the n and m. So here we can write now m minus 1 m minus 1 is equal to n minus 5 over 6. So we know m is equal to n minus 5 over 6 plus 1, so plus 6, so n plus 1 over 6, and here we should find the n, here also n, so I'm going to take here n1, so here also n1, and now we know n1 minus 1 is equal to n minus 3 over 6, so n1 is equal to n plus 3 over 6, and for this integral we know m minus 1 is equal to n minus 1 over 6, so m is equal to n plus 5 over 6, and n1 minus here same as, so n1 is equal to n plus 3 over 6. Okay, then we can write in is equal to, here 1 over 6, here also 1 over 6, so 1 over 6 times digamma of n plus 3 over 6, digamma of n plus 3 over 6, then minus digamma of n plus 1 over 6, so digamma of n plus 1 over 6, then for this integral we know here plus digamma of n plus 3 over 6 minus digamma of n plus 5 over 6. Okay, then still we can simplify a little bit, so we can write 1 over 6 here, digamma of n plus 3 over 6, here also same function, so 2 times digamma of n plus 3 over 6 minus digamma of n plus 1 over 6 minus digamma of n plus 5 over 6. Okay, now we need to I dash of 0, so I am going to differentiate with respect to n, so I dash of n is equal to 1 over 6. We know derivative of digamma function is equal to trigamma function, therefore here we have 2 times trigamma of n plus 3 over 6, and we should multiply by coefficient of n, so 1 over 6, so here 2 over 6, then here also we have minus 1 over 6 trigamma of n plus 1 over 6, then here also 1 over 6 trigamma of n plus 5 over 6. Okay, then we need to I dash of 0, so I dash of 0 is equal to, here we can take 1 over 6 as a common factor, so 1 over 36, and here we have trigamma of 3 over 6, we know 1 half, and here trigamma of, now I'm going to take minus sign as a common factor, so here 1 over 6, then here we know plus trigamma of here 5 over 6. Okay, now we need to digamma of 1 half, trigamma of 1 half, trigamma of 1 over 6, trigamma of 5 over 6. Now we know trigamma of 1 half, trigamma of 1 half is equal to trigamma of 1 half is equal to 5 square over 2. This is a special value of trigamma function, and now how to find digamma of 1 over 6 plus trigamma of 1 over 6 plus trigamma of 5 over 6. Okay, now we can use the reflection formula of trigamma function. So this is the reflection formula. Trigamma of 1 minus c plus trigamma of c is equal to phi square over sine square of phi c. Okay, then if we plug in instead of c, we can take c is equal to 5 over 6, because here 5 over 6 and here 1 over 6. So we know now we have trigamma of 1 minus 5 over 6, we know 1 over 6, plus here trigamma of 5 over 6 is equal to 5 square over, now sine square of 5 times pi over 6. We know sine of 5 times pi over 6 is equal to 1/2. So here square, so 1 over 4. 1 over 4, and this is equal to 4 times 5 square. Okay, then we can write now I dash of 0 is equal to j, our integral, and this is equal to 1 over 36 times trigamma of 1/2, we know 5 square over 2. So here here we have 2, so 2 times pi square over 2, then minus, here we have 4 times 5 square, and here this 2 get cancelled. 5 square minus 4 times 5 square, we know minus 3 times 5 square, and 3 get cancelled, so minus 5 square over 12. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.